Have you ever had that feeling, that deep, nagging suspicion that you're not being told the whole story? That the truth is right there, just behind a veil of static and official explanations, and if you could only pull that curtain back, the world would never look the same again? Just 72 hours ago, the European Space Agency handed us a perfect example. A blurry billion-dollar photo of a fuzzy white dot that has ignited a firestorm of public outrage and deep, unsettling questions. This isn't just about a disappointing picture. This is about 3I Atlas, the third interstellar object ever detected in our solar system, and the story surrounding it is rapidly becoming one of the greatest and most unnerving mysteries of our time. We have seven, count them, seven, advanced orbiters from 4 different space agencies swarming around Mars, all perfectly positioned to get a once-in-a-lifetime look at this visitor from another star. And yet the only thing we've been shown is a smudge that a cast being ridiculed and torn apart on social media, especially when your average backyard astronomer can capture breathtakingly sharp images of comets hundreds of millions of miles farther away. But the frustration is turning into something deeper, something closer to suspicion, because of the silence. A deafening, synchronized global silence. NASA, with its Mars Reconnaissance Orbiter, an eye in the sky so powerful it can spot a kitchen table on the Martian surface, has shown us nothing. Their official excuse? A U.S. government shutdown. An excuse that is wearing thinner by the hour because China's and the UAE's orbiters are also silent. 3 global powers, rivals in space, all deciding not to share images of the most significant celestial visitor of the century? The odds of that are astronomical, and as this object, 3I Atlas, barrels towards the Sun, it's about to enter the single most important phase of its journey, its closest, most violent encounter with our star, and it will be completely hidden from our view. We will be blind. Is this just a series of unfortunate coincidences? Or is something being deliberately kept from us? The famed Harvard physicist Avi Loeb has suggested that what we learn from this object could fundamentally reshape our understanding of the cosmos. So let's pull back that curtain together. Let's look at the evidence, the anomalies, the leaks and the lies, and try to piece together the truth. I want you to be a part of this investigation. As we go through this, like this video, subscribe to the channel, and comment with your location on this planet and what your gut is telling you about 3I Atlas. Share this with anyone you know who looks up at the night sky and wonders. Let's grow this community and demand some answers, because this story is unfolding right now, and what happens next could affect every single one of us. October 7th and 8th, 2025. Mark those dates, because they may go down in history as the moment the public's trust in our space agencies began to fracture. For months, the global community of astronomers, space enthusiasts, and anyone with a shred of cosmic curiosity had been buzzing with anticipation. 3I Atlas, only the third interstellar object we've ever known to visit our solar system, was making its close approach to Mars. This wasn't just another flyby. It was a golden opportunity, a cosmic alignment of epic proportions. 7 of humanity's most advanced spacecraft, our robotic emissaries orbiting the red planet, were in the perfect position to intercept and study this enigmatic wanderer. Was it a comet, a chunk of rock and ice from a distant, long-dead star? Or was it, as some scientists dared to whisper, something more? This was our chance to get answers. We had hardware from NASA, the European Space Agency, ESA, China, and the United Arab Emirates all on station. The combined investment in these missions runs into the tens of billions of dollars. The cameras and sensors on these orbiters are pinnacles of human engineering. The promise was clear. We would get images of unprecedented clarity, data that could finally reveal the true nature of 3I Atlas. Then the photo dropped. Released by the ESA, the image came from their ExoMars Trace gas orbiter. It was taken on October 3rd, from a distance of 30 million kilometers, or about 18.6 million miles. The world leaned in, held its breath, and saw a profoundly, almost insultingly, underwhelming fuzzy white dot. Against a backdrop of distant, sharper-looking stars, the object of our collective fascination was a blurry, pixelated smudge. It offered zero new details. It answered no questions. It was, for all intents and purposes, a cosmic nothing burger. The public reaction was not just disappointment. It was swift, brutal, and laced with ridicule. The Internet, as it is uniquely capable of doing, erupted. A post on the social media platform X, from the popular account Astronomy Vibes, captured the mood perfectly and went viral within hours. It placed the ESA's multi-billion-dollar blur side by side with a stunningly crisp, detailed photo of a completely different comet, Comet Lemon. The kicker? The beautiful photo was taken by an amateur astronomer using a simple mirrorless camera from their backyard. The contrast was jarring, almost comical. The post's caption dripped with sarcasm. 3i Atlas from a multi-billion-dollar orbiter versus a random comet from a backyard. Why can't NASA do better? A follow-up comment, which garnered even more likes, mockingly compared the historic effort to a blurry photo of a weather balloon. It resonated because it touched a nerve of deep public frustration. We were promised a high-definition glimpse into the universe's secrets, and were given a low-resolution shrug. But to truly understand the depth of this anger, we need to look at the cold, hard numbers behind the blur. The camera that took the shot, the Color and Stereo Surface Imaging System, CASIS, on the ExoMars orbiter, is a remarkable piece of technology, but it was designed for a very specific job: photographing the surface of Mars from a close orbit. At the 30 million kilometer distance to 3i Atlas, its resolution translates to a staggering 340 kilometers per pixel. Think about that. A single pixel in that image covers an area larger than the state of Florida. Now, consider the object itself. Scientific estimates place the solid nucleus of 3i Atlas at somewhere between 5 and 46 kilometers in diameter. If we do the math, this highly anticipated interstellar visitor would occupy, at best, about 1/7 of a single pixel. At worst, it would be a mere 1/68 of a pixel. It was always destined to be a dot. Here's the rub. The ESA knew this. They were fully aware of their camera's limitations. Nick Thomas, the principal investigator for the CASIS camera, stated publicly that the observation was extremely challenging. He explained that the comet is up to 100,000 times fainter than Mars, their usual subject. He admitted, "Our cameras were designed for photographing Mars from a short distance, not faint objects millions of kilometers away." This admission raises a far more troubling question than, why is the photo so bad? The real question is, why release an image you knew would be profoundly unsatisfactory, especially after months of building public excitement? The official line, of course, is transparency. They simply shared what they had. But in the world of public relations and strategic communications, that explanation feels thin. Could there have been another motive? Perhaps it was a calculated move, a strategy to release something, anything, to appease the public's demand for information. It's a classic tactic. Release a minor, disappointing piece of data to check the box of transparency, all while potentially withholding more significant, perhaps more complicated, data. It is a strategy that hints at a disturbing possibility: that better images from other spacecraft do exist, and they are being deliberately kept secret. The fuzzy white dot, in this light, wasn't just a failure of technology. It may have been a calculated act of misdirection. While the world was collectively mocking the ESA's blurry image, a far more capable eye was in a prime position to deliver the crown jewel of this entire event. NASA's Mars Reconnaissance Orbiter, MRO, is home to the most powerful camera ever sent to another planet. the High-Resolution Imaging Science Experiment, or HiRISE. To call HiRISE a camera is a gross understatement. It's a telescopic marvel. From its orbit, it can resolve objects on the surface of Mars down to the size of a kitchen table. It has gifted us with breathtaking images of Martian avalanches, dust devils, and the tracks of rovers from decades past. It is, without exaggeration, humanity's sharpest eye in deep space. On October 3rd, as 3I Atlas made its closest approach, HiRISE was perfectly positioned. At that distance, calculations show it could have achieved a resolution of about 30 kilometers per pixel. That is more than 10 times better than the ESA's Cassis camera. A tenfold increase in resolution is not just a minor improvement, it's a leap into a different dimension of detail. While Cassis could only show 3I Atlas as a fraction of a pixel, HiRISE could have resolved it into multiple pixels. This is a critical distinction. A single pixel tells you nothing but brightness. Multiple pixels can begin to reveal a shape. They can show if the object is elongated, if it has an irregular form, or if there are any unusual structures or features casting shadows. If 3I Atlas is anything other than a simple uniform sphere, HiRISE would have detected it. The significance of this was not lost on the scientific community. Harvard physicist Avi Loeb, a leading and often controversial voice in the search for extraterrestrial intelligence, has been following the 3I Atlas event with intense focus. On October 7th, he penned a blog post emphasizing the immense value of the potential HiRISE image. He wrote that it would provide the best yet constraints on the object's area, and expressed his fervent hope for its quick release. That hope was shared by millions. October 7th came and went. Then October 8th. Silence. Not a pixel. Not a press release. Not even a holding statement from NASA. The official reason provided for this deafening silence is the ongoing U.S. government shutdown. This political stalemate has furloughed over 80% of NASA's workforce, effectively grinding public communications and many non-essential operations to a halt. On the surface, it's a plausible, if frustrating, excuse. NASA can't release what it can't process or communicate. But this excuse begins to crumble under the slightest scrutiny. Firstly, the ESA, as a European agency, is completely unaffected by American politics. They released their image, blurry as it was. More importantly, two other independent, powerful spacefaring nations had their own assets in prime position. China's Tianwen-1 orbiter and the United Arab Emirates' Hope orbiter were also circling Mars, both equipped with capable cameras. China and the UAE are not beholden to the U.S. government. They are, in fact, strategic rivals to the United States in the domain of space exploration. If there were a spectacular, non-threatening natural phenomenon to be observed, one would expect them to seize the opportunity for a major scientific and public relations victory. Announcing a groundbreaking discovery or releasing a stunning image while NASA is hamstrung would be a geopolitical coup. Yet, from Beijing and Abu Dhabi, there has been nothing but the same profound silence we've heard from Washington, D.C. This is the detail that transforms the situation from merely frustrating to deeply suspicious. The synchronized silence from three independent competing space agencies is a statistical anomaly in itself. It has ignited a firestorm of speculation across social media and online forums. The theories range from the mundane to the extraordinary. Perhaps the data is so complex that all the agencies have entered into a coordinated, behind-the-scenes review before releasing anything. A less charitable but perhaps more plausible theory is that the images revealed something so anomalous, so utterly strange, that releasing them without a carefully prepared narrative and context could risk widespread confusion or even panic. While the idea of a discovery that could cause mass panic sounds like the plot of a Hollywood blockbuster, the context here is crucial. The silence from the professionals is creating an information vacuum, and that vacuum is being filled by startling observations from a different source entirely. Amateurs on the ground who are seeing things that the professionals, for whatever reason, won't show us. The story was no longer just about a blurry photo. It was about the chilling possibility that our own governments were hiding something right in our cosmic backyard. Before we dive deeper into the bizarre observations surrounding 3I Atlas, it's crucial that we establish a baseline. What does a normal visitor to our solar system look and act like? The universe is a busy place, and objects fly through our neighborhood all the time. Understanding the predictable helps us appreciate the truly strange. In a perfect stroke of cosmic timing, October 2025 has provided us with some excellent examples of what to expect. On October 1st, just as the drama around 3I Atlas was beginning to build, an asteroid the size of a giraffe, now named 2025 TF, whizzed past our planet. It came closer to Earth than the orbit of the International Space Station, a hair's breadth in cosmic terms. And here's the unsettling part. We didn't see it coming. It was only detected after it had already passed us and was heading back out into the void. This event is a startling and humbling reminder of a fundamental truth. Despite our incredible telescopes that can peer into distant galaxies, we still have significant blind spots right here at home. We can miss near-Earth objects traveling at tens of thousands of miles per hour. So, should this worry us? In the case of 2025 TF, not really. At the size of a giraffe, it was small enough that it would have harmlessly burned up in our atmosphere had it entered on a collision course. But it serves as a powerful illustration of the cosmic shooting gallery we live in. NASA and the ESA prioritize tracking the big ones, the planet killers over 140 meters in diameter, which is why a smaller visitor like this can slip through the net. Space is filled with this kind of debris, ancient rocky remnants from the formation of our solar system billions of years ago. They follow predictable orbits governed by gravity, and occasionally, a gravitational nudge sends one our way. They are the known, the understood, the baseline. In stark contrast to this stealthy asteroid, another cosmic guest is making a much grander entrance. Comet C 2025 A6, Lemon, is currently gliding through our skies, and it's putting on a spectacular show. It's brightening day by day, and is on the verge of becoming visible to the naked eye. For astrophotographers and backyard skygazers, it's a gift. Unlike the surprise asteroid, Comet Lemon has been tracked since its discovery. We know its orbit, we know its composition, and we can predict its behavior, to a point. Comets are fundamentally different from asteroids. They are often called dirty snowballs for a reason. They are conglomerates of ice, dust, and rock that formed in the frigid outer reaches of our solar system, in a vast reservoir of primordial material called the Oort cloud. As a comet's long elliptical orbit brings it closer to the Sun, the solar radiation begins to heat its surface. The ices don't melt. They sublimate, turning directly from a solid into a gas. This process releases a huge cloud of gas and dust that forms a glowing atmosphere around the nucleus, called a coma. The solar wind then pushes this material away, creating the comet's iconic, beautiful tail, which always points away from the Sun. We'll even have a second comet, C 2025 R2, Swan, gracing our skies this month, visible with a good pair of binoculars. These comets are not just beautiful, they are time capsules. They are made of the most pristine, unaltered material from the birth of our solar system, 4.6 billion years ago. Scientists believe that in Earth's violent youth, comets like these may have been the delivery vehicles that brought water and the essential organic building blocks of life to our nascent planet. So when you look at a comet, you are seeing a direct link to the origins of everything we know. They are predictable, they are natural, and they are part of our story. They are what 3I Atlas is supposed to be. But the evidence is mounting that it is something else entirely. On October 3rd, the very same day that 3I Atlas silently slipped past the fleet of orbiters at Mars, a Portuguese amateur astronomer, known online as Dobsonian Power, uploaded an image to his social media that would pour gasoline on the fire of public suspicion. Using a solar telescope, a detail that will become very important, he captured and digitally enhanced a photo of the interstellar object. The result went viral almost instantly. The image was shocking. Instead of a fuzzy, comet-like glow, it appeared to show a distinct angular structure nestled within the object's coma. There were dark, almost geometric shapes, features that looked utterly unnatural and completely out of place for a dirty snowball. His caption was simple and honest, reflecting his own bewilderment. "What on earth is it?" The image spread like wildfire through astronomy forums, Reddit threads, and X. It immediately and violently divided the online community. One camp saw it as the smoking gun, clear and undeniable evidence of an artificial structure, a probe or ship from another civilization. This was the proof the agencies were hiding. The other camp, composed largely of scientific purists and professional astronomers, immediately dismissed it as a classic case of pareidolia, the universal human tendency to perceive meaningful patterns in random noise. Our brains are wired to see faces in clouds and figures in shadows, they argued. And this was simply a digital version of that, exacerbated by the improper use of scientific equipment. The critics did have a valid point. Solar telescopes are highly specialized instruments designed for one purpose: looking at our own sun, an incredibly bright and close object. They are not built to capture faint, deep space objects like 3I Atlas. To get any image at all, Dobsonian Power would have had to push his equipment to its absolute limits, and then apply aggressive digital enhancement techniques to bring out any detail from the noise. This process, they argued, could easily create artificial details, or artifacts, that look real but are just phantoms in the data. However, Dobsonian Power is not some random internet troll or a peddler of fake news. He is a respected member of the amateur astronomy community, with a long and credible history of excellent work. He approached his own findings not with sensationalism, but with scientific caution. He openly acknowledged the uncertainty, admitted the limitations of his equipment, and promised to re-observe the object in November with different instruments to try and confirm his findings. He was behaving like a true scientist. The reaction to his image from certain corners of the internet was far more telling than the image itself. Within 24 hours, a flurry of articles and blog posts appeared, all with one specific purpose: to debunk his capture. The tone of these articles was strangely coordinated and intensely defensive. They weren't just explaining the science of digital artifacts. They seemed aimed at aggressively controlling the public narrative, at shutting down the conversation before it could even begin. This heavy-handed attempt at debunking backfired spectacularly, creating what can only be described as an enhancement war. Sparked by the controversy, thousands of people across the internet began to download the original blurry ESA images and process them with every tool at their disposal, including sophisticated AI upscaling software. The results were a chaotic and fascinating flood of new images. Some were just slightly sharper white dots. Others, however, showed distinct geometric patterns, chevrons, and even what looked like metallic surfaces. Now, it is absolutely critical to understand that this method is not scientifically reliable. AI upscalers in particular can be dangerously misleading. They are trained on vast datasets of existing images, and when asked to add detail to a blurry source, they can essentially hallucinate or invent details based on what their training data suggests should be there. If an AI has been trained on images of machines, it might invent machine-like details. But this flood of enhanced images, both the plausible and the obviously fake, had a profound effect. It successfully muddied the waters. Amidst the noise of fabricated images showing alien thrusters and metallic hulls, a few more subtle, more compelling images emerged from different users, all hinting at similar, non-natural structures. This created a maddening paradox. Were real, anomalous features being deliberately obscured by a deluge of hoaxes and bad faith enhancements? Or was the entire phenomenon just a grand exercise in collective wishful thinking? The truth was becoming impossible to discern, and it felt like that might have been the goal all along. Just as the internet was descending into chaos over amateur photos and AI enhancements, a new and far more potent piece of the puzzle emerged from one of the web's most infamous corners. On October 4th, a post appeared on 4chan's paranormal board, X. The anonymous user claimed to be a doctoral researcher working within the European Space Agency, and they offered what they alleged was insider information about the true nature of 3I Atlas. Ordinarily, a claim like this from an anonymous 4chan user would be dismissed instantly as a classic internet hoax. But this post was different. It lacked the usual sensationalism and spelling errors of typical online fabrications. Instead, it was filled with a high level of technical detail, presenting a series of specific, quantifiable observational anomalies that directly challenged the official narrative of a simple, natural comet. It read like it was written by a scientist. The post laid out 3 core anomalies that, if true, would be scientific bombshells. The first was described as a chemical impossibility. According to the leak, spectroscopic analysis of the gas surrounding 3I Atlas had revealed something deeply strange. The object was reportedly ejecting about 100 kilograms of nickel gas every single second. In itself, that's just a measurement. But the anomaly was what was missing. There was almost no corresponding emission of iron. This is highly unusual. In virtually all known cosmic objects, from asteroids to meteorites, nickel and iron are found together, like cosmic cousins. They are forged in the same stellar processes and are almost always found in predictable ratios. To find a massive plume of nickel with virtually no iron is like finding a forest with leaves but no trees. It points to an artificial process, a material that has been refined or engineered. The second anomaly was a thermal contradiction. The object is outgassing, releasing gas and dust, like a comet that is being intensely heated by the sun. We can see its coma and tail. However, thermal readings allegedly show that the object itself remains far colder than it should be. This is a physical inconsistency. The outgassing is a direct result of solar heating causing ice to sublimate. For the object to be producing such a large coma while remaining mysteriously cold is like finding a boiling pot of water that is still cold to the touch. It defies the known laws of thermodynamics, unless some other non-solar energy source is at play, causing the outgassing from within. The third anomaly concerned its trajectory precision. The post elaborated on public statements already made by Avi Loeb, but with a more dramatic claim. It alleged that the object's path through space is a perfect straight shot from the galactic core. It shows no signs of the tiny gravitational disturbances one would expect an object to accumulate over a journey of millions, perhaps billions, of years. It's moving as if it's on rails, a trajectory so precise it seems guided. The anonymous user then synthesized these anomalies into a shocking hypothesis. They claimed the object fits the profile of a post-biological entity, equipped with a 3-phase particle engine that is actively probing our solar system. This wasn't just a rock. It was a machine, and it was intelligent. To cap it all off, the post introduced a concept from the bleeding edge of theoretical physics. It speculated that 3I Atlas could be a cue ball. This sounds like pure science fiction, but cue balls are a real, albeit highly theoretical, type of macroscopic quantum object. If they exist, they would be super-dense, stable remnants from the early universe. The post argued that a cue ball could potentially explain all the observed anomalies. Its density could account for its precise trajectory. Its unique energy distribution could explain the thermal contradiction, and its exotic nature could be responsible for the bizarre chemical signature. The leak quickly escaped the confines of 4chan and spread across the internet. It sparked intense debate, with physicists and astronomers weighing in on the plausibility of the claims. Predictably, on many mainstream platforms like Reddit, moderators quickly locked down or deleted the threads, citing the claims as unverified. But this act of suppression only fueled more conversation elsewhere. It was another case of the Streisand effect. The harder the establishment tried to silence the story, the more people believed there must be something to it. The 4chan leak, whether a brilliant fiction or a terrifying truth, had provided a coherent and scientifically detailed framework for all the strangeness surrounding 3I Atlas. It proposed that the blur, the silence, and the anomalies weren't a series of coincidences, but pieces of a single, unbelievable reality. Just one day after the 4chan leak on October 4th, the mystery deepened. This time the source wasn't an anonymous insider, but one of NASA's own crown jewels, the Perseverance rover on the surface of Mars. The rover's cameras are often used to look up at the Martian sky, capturing images of Mars's tiny moons, Phobos and Deimos, and even the occasional meteor. On this day, it captured an image of a long, thin, streak-like object passing through the night sky. When the image was first shared among online astronomy communities, people immediately began to do the math. Based on the rover ES camera specifications, its field of view and resolution, and the known distance to 3I Atlas at that specific time, they arrived at a jaw-dropping conclusion. For the streak to be that long in the image, the object itself would have to be a staggering 50,000 kilometers long. That's nearly 31,000 miles. To put that in perspective, the diameter of planet Earth is only about 12,700 kilometers. This object, if the calculation was correct, was a cylindrical craft almost 4 times the diameter of our own world. The speculation exploded. This was it. 3I Atlas was not a comet. It was a colossal, cigar-shaped mothership, a craft of such immense scale that it beggared belief. It was hiding its true size within its glowing coma, and for a brief moment, from the unique vantage point of the Martian surface, its true form had been revealed. The timing was almost too perfect. It came just a day after the Mars flyby, in the midst of the synchronized silence from the space agencies, and seemed to confirm the most extreme theories. Something truly anomalous and massive had just passed through the heart of our solar system. The online frenzy grew to such a pitch that it broke through into the mainstream and reached the halls of power. In a highly unusual move, U.S. Representative Anna Paulina Luna publicly contacted Harvard physicist Avi Loeb, forwarding him the image and the surrounding speculation, and asking for his expert analysis. This wasn't just online chatter anymore. It was a question being posed at the intersection of science and government. Loeb's response, when it came, was a masterclass in scientific reason, but with a crucial, tantalizing caveat. On the surface, his analysis was reassuring and seemed to debunk the giant spaceship theory entirely. He explained that the 50,000-kilometer length was almost certainly not the object's actual size, but rather an artifact of the way the image was taken. It was, he argued, a long-exposure photograph. To understand this, think about taking a picture of a highway at night. If you leave your camera's shutter open for a few seconds, the headlights and taillights of the cars don't appear as dots. They appear as long streaks of red and white light, tracing the path the cars took while the shutter was open. Loeb proposed the same thing was happening here. The Perseverance rover had likely left its shutter open for about 10 minutes. During that time, 3I Atlas, moving across the Martian sky, would have painted a long streak across the camera's sensor. The length of the streak wasn't the size of the object, but a visual record of its motion over time. He even did the calculations, factoring in the relative velocities of Mars in its orbit and 3I Atlas on its trajectory. Case closed, right? The rational explanation had won. But Avi Loeb, ever the meticulous scientist, included a critical qualifier in his analysis that kept the door to mystery wide open. He stated that his entire calculation was based on the assumption that the image was a long-exposure composite. He then added that if the images were, in fact, single snapshots with a very short exposure time, then the observed streak could not be 3I Atlas. It would have to be something else entirely, something much, much closer to the rover. And here is the linchpin of the entire controversy. NASA has not released the image's metadata. That metadata, a simple data file attached to the image, would instantly confirm the exposure time and settle the debate once and for all. Why has this crucial piece of information been withheld? The official reason, once again, is the government shutdown. But this excuse feels particularly weak here. Releasing a tiny text file of metadata would require minimal effort, far less than releasing the image itself. So, we are left suspended between two realities. One is the calm, rational explanation of a photographic artifact, a simple illusion of motion. The other is the wild, almost unthinkable possibility that the Perseverance rover photographed something else entirely. A 50,000-kilometer-long object that was not 3I Atlas, but something unknown that just happened to be flying through the Martian sky at the exact same time. The silence from NASA on this simple technical question has allowed the most extreme possibility to remain stubbornly on the table. This cascade of anomalies, the deliberate blur, the coordinated silence, the amateur's angular object, the insider leak, the 50,000-kilometer question mark, forces us to confront a possibility that most of science has been reluctant to touch for decades. Could this be technology? Could 3I Atlas be a probe, a ship, a piece of hardware from a civilization beyond our own? And if it is, where could it possibly have come from? For a long time, the answer was a shrug. The universe is vast, and the chances of life, let alone intelligent life, finding us seemed infinitesimally small. But recent discoveries are rapidly changing that calculation. We are now finding that the ingredients for life and the potential homes for it are far more common than we ever dared to imagine. Let's start with the cradles themselves. For a planet to host life as we know it, it needs to be in the Goldilocks zone of its star. Not too hot, not too cold. But what about moons? In our own solar system, some of the most promising candidates for life are not planets, but the icy moons of Jupiter and Saturn, like Europa and Enceladus. These worlds are thought to have vast, liquid water oceans hidden beneath their icy shells, kept warm by the tidal forces of their parent planets. For decades, we've theorized that moons around exoplanets, exomoons, could be even more numerous than exoplanets themselves, dramatically expanding the number of potentially habitable worlds in the galaxy. The problem was, we'd never seen one being formed. Until now. The James Webb Space Telescope, our magnificent new eye on the cosmos, has just provided the first-ever direct measurements of a moon-forming disk around a young exoplanet. The planet, named CT-Cha b, is located 625 light-years away. It orbits a star that is only 2 million years old, a mere infant in cosmic terms. This means we are witnessing a planetary system in the process of being born. Around this baby gas giant, Webb detected a swirling disk of gas and dust, the raw material for moons. And within that disk, it found the chemical signatures of key molecules like hydrogen cyanide, acetylene, and benzene. These aren't just random chemicals. They are carbon-bearing molecules, the essential building blocks for life. This is a landmark discovery. We are getting a real-time glimpse into a process that we believe formed Jupiter's Galilean moons billions of years ago. It shows us that moon formation is likely a common and robust process throughout the universe. Every gas giant we find could be orbited by a collection of potentially habitable, ocean-bearing worlds. Suddenly, the number of places life could arise skyrockets. But what about life itself? Finding a cradle is one thing. Finding the seeds is another. For that, we turn back to Mars. In September 2025, findings published in the prestigious journal Nature sent a jolt through the astrobiology community. A rock sample collected by NASA's Perseverance rover contains the strongest evidence yet for past microbial life on the red planet. The sample was drilled from a rock nicknamed Chow, the Navajo word for frog, located in what was once an ancient riverbed. Inside this rock, scientists found a unique and tantalizing combination of organic carbon, sulfur, iron, and phosphorus. Most intriguing of all are tiny, mottled features that researchers have nicknamed leopard spots. These spots are highly enriched with iron phosphate and iron sulfide. Why is that so exciting? Because on Earth, these precise chemical arrangements are often the byproducts of microbial metabolism. They are the chemical footprints that bacteria leave behind as they live and process energy. Now, the scientists are being extremely cautious. They are calling this a potential biosignature, not definitive proof of life. They are haunted by past controversies, like the 1996 claim of fossilized bacteria in a Martian meteorite that remains debated to this day. It's possible, they admit, that some unknown, non-biological geological process could have created these same patterns. But the rocks where these spots were found are relatively young, geologically speaking. This suggests that Mars may have been habitable, and perhaps inhabited, for much longer than we previously thought. The ultimate answer will have to wait for the ambitious Mars Sample Return mission, which aims to bring these very rocks back to Earth in the 2030s for analysis with our most powerful instruments. Think about the implications of these two discoveries together. One shows us that the universe is abundantly supplied with potential homes for life, habitable moons. The other provides the strongest hint yet that life did, in fact, arise on another world right here in our own solar system. When you consider this new context, the idea of an interstellar visitor being a piece of technology doesn't seem so outlandish. If life is common, and if it can arise on planets and moons across the galaxy, then it's statistically inevitable that some of it would have evolved intelligence, developed technology, and begun to explore. The question is no longer, are they out there? The question is becoming, are they right here? To truly grasp the chilling significance of 3I Atlas, we have to travel back in time, back almost half a century, to a moment when a radio telescope in Ohio listened to the cosmos and heard a whisper that has haunted us ever since. On August 15, 1977, the Big Ear Radio Telescope at Ohio State University was conducting a survey for the Search for Extraterrestrial Intelligence, SETI. Suddenly, it detected a powerful, narrow-band radio signal lasting for a full 72 seconds. It was unlike anything it had ever detected before. It was structured, intense, and occupied a sliver of the radio spectrum that was tantalizingly close to what we call the hydrogen line, a universal frequency that scientists have long theorized an alien intelligence might use to broadcast a signal. The astronomer on duty that night, a man named Jerry Amon, was reviewing the computer printouts of the data days later. When he saw the anomalous signal, a sequence of characters 6EQUJ5, he was so stunned by its perfect resemblance to an expected extraterrestrial signal that he famously circled it in red pen and wrote a single word in the margin: "Wow." The wow signal has since become one of the greatest unsolved mysteries in modern science. It was a perfect candidate for an alien transmission, but there was one massive problem. Despite numerous follow-up observations of the same patch of sky by telescopes all over the world, it was never, ever detected again. It was a ghost in the machine, a one-time cosmic shout that faded back into silence. For 48 years, it has remained a tantalizing but frustrating footnote in the history of science. Until now, Avi Loeb, the same Harvard physicist analyzing the Perseverance rover image, recently made a connection so startling, so statistically improbable, that it reframes this entire mystery. He asked a simple question: where was 3I Atlas in August of 1977? Using its current trajectory, He calculated its position back in time. What he found is breathtaking. On August 12, 1977, just 3 days before the "wow" signal was detected, the object we now call 3I Atlas was approximately 600 astronomical units from Earth. 1 AU is the distance from the Earth to the Sun. And, crucially, it was coming from a direction in the sky only 9 degrees away from the source of the wow signal. This is an astonishingly close alignment. The sky is a vast expanse. For these two extremely rare events, the detection of our most promising SETI signal and the arrival of our most anomalous interstellar object, to originate from almost the exact same point in space and time, is a coincidence of epic proportions. Loeb calculated the probability of such an alignment happening by chance. The result is less than 1%. He then took his hypothesis a step further. He calculated what it would have taken for 3I Atlas to have sent the wow signal from that distance. The answer? It would have required a transmitter with a power output of between 0.5 and 2 gigawatts. This sounds like a lot, and it is. It's comparable to the output of a small nuclear power plant. But for a civilization capable of interstellar travel, is that an unreasonable amount of power to focus into a directional broadcast? It's entirely plausible. Adding another layer of confirmation, the original wow signal had a distinct blue shift in its frequency. This means the source of the signal was moving rapidly toward us. This is perfectly consistent with 3I Atlas's current trajectory. Loeb even speculates that the object could have been moving slower back in 1977, and perhaps accelerated after detecting signs of habitable planets, like the oxygen in Earth's atmosphere, in our solar system. The 72-second duration of the signal could even correspond to the time it took for the Big Ear telescope's beam to sweep past the object. This is a hypothesis, but it's a powerful one because it's testable. If 3I Atlas is the source of the wow signal, it might still be transmitting. All we have to do is point our most powerful radio telescopes at it and listen, specifically around the hydrogen line frequency, where the original signal was detected. We have the instruments to do this. The Very Large Array, VLA, in New Mexico and the Green Bank Telescope in West Virginia are two of the most sensitive radio observatories on the planet. And yet, as Avi Loeb himself has pointed out with increasing frustration, there has been a deafening silence from the entire radio astronomy community. No major radio telescope has reported any observations of the object. The SETI Institute has not announced any official monitoring efforts. It is an almost unbelievable dereliction of scientific duty. We have a potential 48-year-old message from the stars, a possible source for that message currently flying through our own solar system, and the world's best ears seem to be deliberately pointed in the other direction. This silence, more than anything else, deepens the mystery and lends a chilling credibility to the idea that there is a truth about 3I Atlas that we are not being told. The possibility that 3I Atlas could be an alien technology, a probe that sent the wow signal decades ago, forces our minds into uncomfortable territory. What would such a technology even look like? The concepts mentioned in the 4chan leak, a post-biological entity with a 3-phase particle engine, sound like pure fantasy. But are they? Or are they just logical extrapolations of the very technologies we are beginning to develop right now? Perhaps the most unsettling part of this story is that for the first time in human history, we can look at our own bleeding-edge science and see a faint reflection of what an interstellar civilization might create. Let's start with the idea of a post-biological entity. For much of our history, we've imagined aliens as biological creatures, little green men in silver suits. But this is likely a projection of our own limitations. A civilization capable of traversing the immense, hostile distances between stars might quickly realize that fragile biological bodies are not suited for the task. The next logical step would be to merge with their technology, to become something post-biological, a consciousness housed in a more resilient, more capable, robotic, or synthetic form. Or perhaps they would create a pure artificial intelligence, a silicon mind to send out on their behalf. Does that sound like science fiction? In 2025, it's beginning to sound like a research and development roadmap. The AI revolution is no longer a future prediction. It's our daily reality. But while many of us are still getting used to asking chatbots for recipes, the cutting edge of AI is pushing into realms that are truly transformative. In the sciences, AI is now being used to simulate the complex folding of proteins, dramatically accelerating the discovery of new drugs. Researchers have used AI to create the most detailed maps of the human brain ever conceived, revealing its intricate organization in ways we never could before. Another new AI can now identify different types of brain cells just by listening to their unique electrical signals. A massive breakthrough for neuroscience and the development of brain-computer interfaces. As AI becomes more integrated into our world, we're seeing the rise of autonomous AI agents, AIs that can be given a complex goal and can then execute a series of tasks to achieve it without human intervention. These are the primitive ancestors of the very silicon mind that could one day pilot an interstellar probe. We are simultaneously grappling with the immense ethical and legal questions that arise when these agents make mistakes. The next generation of AI is focused on overcoming current limitations, like a lack of common sense and a tendency to hallucinate incorrect information. We are building the ghost in the machine, and we're just at the very beginning of that journey. What about the three-phase particle engine? How would such a craft be powered? Again, we can look to our own labs for a clue. In February 2025, scientists at the West Tokamak reactor in France achieved a new world record in the quest for nuclear fusion energy. They successfully created and sustained a plasma at 50 million degrees Celsius, hotter than the core of the Sun, for an incredible 22 minutes and 17 seconds. This is a monumental step toward harnessing the same process that powers the stars. Fusion works by forcing atoms together to release immense amounts of energy. The fuel, derived from water and lithium, is abundant, and the process creates no carbon emissions or long-lived radioactive waste. It is the holy grail of clean energy. For decades, practical fusion power has been 30 years away. But now, with massive public and private investment and rapid breakthroughs in reactor design and plasma physics, some companies believe they can demonstrate a net energy gain by the end of this decade. While our first fusion reactors will be enormous power plants on the ground, it's not a huge leap to imagine this technology being miniaturized to power a spacecraft, providing the immense, sustained energy needed for interstellar travel. A particle engine could very well be a sophisticated form of fusion or matter-antimatter propulsion. Finally, how would such an advanced entity compute and navigate? A journey of millions of years would require calculations of mind-boggling complexity. Here, too, 2025 has marked a turning point, as quantum computing transitions from a laboratory curiosity to a practical reality. In late 2024, a major breakthrough was achieved when Microsoft and Atom Computing successfully created and entangled 24 logical qubits. This is a huge deal. Classical computers use bits, which are either a 0 or a 1. Quantum computers use qubits, which can exist in a superposition of both 0 and 1 at the same time. This allows them to process information and solve certain types of problems exponentially faster than any classical computer ever could. The primary challenge has always been that qubits are incredibly fragile and prone to errors. The new breakthrough is in quantum error correction, creating stable and reliable logical qubits. This has spurred a global race, with companies like Google, IBM, and Amazon all pushing the technology forward. We are building machines that harness the fundamental strange language of the universe to solve problems once thought intractable. Optimizing a billion-year trajectory through a galaxy filled with gravitational fields? That is precisely the kind of problem a quantum computer would be perfect for. When we look at these three fields together, artificial intelligence, fusion energy, and quantum computing, we can see the faint outlines of the very technology that 3i Atlas is accused of being. It no longer seems impossible, just advanced. The most unsettling thought is that if this object is indeed a technological artifact, it's not magic. It's just physics and engineering, taken to a level that we ourselves are just beginning to dream of. Of all the anomalies surrounding 3i Atlas, there is one that is perhaps the most difficult to dismiss as a coincidence because it's baked into the very fabric of its journey. It is the simple, cold, statistical improbability of its trajectory. The path it took to enter our solar system simply shouldn't exist. Imagine a blindfolded person standing on one side of a large room. On the other side of the room is a spinning globe. Their task is to throw a single dart and hit the globe somewhere near its equator. The odds are overwhelmingly against them. They are far more likely to miss the globe entirely, or to hit it at a high latitude near one of the poles. Hitting it on that narrow band of the equator would be a shot of incredible, almost unbelievable precision. This is a near-perfect analogy for the arrival of 3i Atlas. Our solar system does not sit flat within the Milky Way galaxy. The galactic disk itself is tilted at a steep 60-degree angle relative to the plane in which Earth and the other planets orbit the Sun, our ecliptic plane. Furthermore, the stars within our galaxy are not moving in orderly lines. They have random motions, buzzing around like bees in a hive. Therefore, any object that is naturally ejected from one of these star systems, a comet, an asteroid, should arrive at our solar system from a completely random direction. We should be hit by these interstellar visitors from above, from below, and from all angles in between. The vast majority should arrive at steep, dramatic angles. This is exactly what we saw with the first two interstellar objects. The first, the famous Oumuamua, arrived at a steep 123-degree inclination. The second, 2I Borisov, came in at a more moderate but still significant 44 degrees. Both of these objects behaved exactly as statistical models predict. They were the equivalent of the dart hitting the globe at a random high-latitude spot. They were natural. Then came 3i Atlas. It entered our solar system with an orbital inclination of just 4.89 degrees. This is an almost perfectly flat trajectory, almost exactly aligned with the plane of our own planets. It's the dart that, against all odds, hit the spinning globe squarely on the equator. The statistical likelihood of this happening for a random object is, by some calculations, in the top 1%. Even if we use the most conservative estimates, the probability is still no higher than 10%. For only the third interstellar object we've ever detected to be such a rare, 1 in 10 or even 1 in 100 case is highly suspicious. Skeptics might argue that this is a case of the prosecutor's fallacy. This is a logical error where you focus on a single, low-probability event and conclude that it must have a special cause, while ignoring all the other random events happening around it. It's like dealing a hand of poker, getting a royal flush, and concluding the deck must be stacked. A royal flush is rare, but if you play enough hands, it's bound to happen eventually. Maybe, they argue, we just got lucky with 3i Atlas. But this argument weakens when you don't look at the trajectory in isolation. The improbability of its path is just one piece of the puzzle. You have to stack it on top of all the other anomalies. The alignment with the wow signal, a less than 1% probability. The unusual chemical and thermal properties described in the leak. The synchronized withholding of high-resolution images by multiple competing space agencies. When you combine these independent, low-probability events, it becomes much harder to dismiss them as a string of unrelated coincidences. The counter-argument becomes far more compelling. Perhaps we should take the evidence at face value. Perhaps the reason its trajectory looks so unnatural is because it isn't natural. Perhaps the reason it seems so precisely aimed is because it was aimed. A trajectory this precise is not what you would expect from a random chunk of rock and ice, but it is exactly what you would expect from a probe on a deliberate mission of reconnaissance. As the on-the-ground mystery of 3I Atlas deepened, a second, more insidious story began to unfold in the digital world. Around October 5th, just as public frustration and speculation were reaching their peak, a strange and coordinated pattern of content suppression began to emerge across every major social media platform. The digital curtain was falling. Users who were posting detailed analyses or asking pointed questions about the object's anomalies began to notice their content was disappearing. One highly detailed post on Reddit, which compiled all the available evidence and poked holes in the official narratives, gained significant traction, hitting the front page of several science-related subreddits. Within hours, it was deleted by moderators without explanation. The user who wrote it was subsequently shadow banned, their future posts and comments rendered invisible to others. On X, the platform formerly known as Twitter, popular science communication accounts like Astronomy Vibes, the same one that had gone viral for criticizing the ESA's photo, noticed a sudden and dramatic drop in their engagement. Their posts, which had been getting tens of thousands of likes and shares, were suddenly getting only a few hundred. Their content was no longer being pushed by the algorithm. It was being actively suppressed, hidden from the feeds of their own followers. The story was the same on YouTube. Creators who produced videos speculating about the anomalies of 3I Atlas, discussing the 4chan leak, or questioning the silence from NASA, began receiving demonetization notices. The official reason cited was that they were discussing sensitive or misleading scientific topics. Meanwhile, videos that towed the official line, dismissing the controversy and reinforcing the mainstream "it's just a comet" narrative, remained fully monetized and were often promoted by the platform's recommendation engine. Perhaps most overtly, Facebook's powerful fact-checking system went into overdrive. Posts discussing 3I Atlas were aggressively labeled as missing context or partly false. These labels would appear even when the posts were simply quoting the published calculations of respected scientists like Avi Loeb, or accurately reporting on the existence of the amateur images and the 4chan leak. The fact checks themselves consistently pushed a reassuring, almost paternalistic narrative. There is no mystery here. The authorities have it under control, and any speculation to the contrary is irresponsible conspiracy mongering. This coordinated wave of suppression was not random. It ramped up within a 48-hour window immediately following the release of the ESA's photo, the very moment when public distrust and anger were at their highest. While content moderation and suppression are normal, if often controversial, functions of these platforms, the synchronized targeting of a single specific scientific topic at a moment of peak public interest created a pattern that was impossible to ignore. And of course, it had the opposite of its intended effect. Instead of quelling the conversation, it fueled the very conspiracy theories it was supposedly trying to fight. The more the conversation was controlled, the more people became convinced that there was something to hide. Creators began using coded language and memes to evade the algorithmic censors, which only amplified the sense of a clandestine community sharing forbidden knowledge. It was a textbook demonstration of the Streisand effect. By trying to draw a curtain over the mystery of 3I Atlas, the powers that be only convinced more people to desperately peek behind it. We now arrive at the climax of this entire cosmic drama. On October 29th and 30th, 3I Atlas will make its closest approach to the Sun, a moment known as perihelion. This is the point of maximum danger and maximum revelation for any object visiting from the outer solar system. It is the moment of truth. As it swings around our star, 3I Atlas will be subjected to an almost unimaginable onslaught of heat and gravitational forces. It will be hammered on the solar anvil. For a natural comet, this is a moment of spectacular violence. The intense solar radiation should cause it to outgas dramatically, brightening by orders of magnitude as its ices and volatile compounds are boiled away into space. The gravitational stress could be enough to tear the object apart completely, causing it to fragment into multiple smaller pieces. If 3I Atlas is just a dirty snowball, this is when it will show its true nature, erupting in a final brilliant display before continuing its journey back out into the void, forever scarred by its encounter. This is the critical observation that could solve the entire mystery. Seeing how it behaves at perihelion would tell us more than any single image ever could, and we will not be able to see it. In a twist of orbital mechanics that feels almost suspiciously convenient, during this crucial 2-day period, 3I Atlas will be on the opposite side of the Sun from Earth. It will be completely hidden from the view of every single ground-based and space-based telescope we have. We will be completely and totally blind during the most important phase of its entire encounter. Avi Loeb has laid out the two starkly different scenarios for what might happen while the object is hidden from our view. Scenario 1 is the natural comet hypothesis. In this case, it will likely erupt, fragment, or even disintegrate under the Sun's intense heat. When it re-emerges into our view in early November, we will see either a much fainter object, a cloud of debris where the object used to be, or multiple smaller objects traveling along a slightly altered path pushed by the force of the outgassing. If this happens, the mystery will be largely resolved. Scenario 2 is the technological object hypothesis. If 3I Atlas is a probe or a craft, this moment of perihelion is not a danger, but an opportunity. It could use the Sun's immense gravity for a slingshot maneuver, a gravity assist to dramatically alter its course and speed without using any fuel. More alarmingly, it could use the cover of its passage behind the Sun to deploy smaller probes. Because of its retrograde orbit, moving in the opposite direction to the planets, calculating an intercept trajectory to Earth from that position is a relatively simple astrogation problem. Loeb has gone so far as to issue a stark public warning. He has stated that if 3I Atlas does maneuver and change its trajectory toward Earth after it reappears from behind the Sun, the resulting existential uncertainty and fear could cause global financial markets to crash. The situation is a perfect storm of ignorance and high stakes. NASA is effectively offline due to the shutdown. The high-resolution images that could have given us a clue about its nature remain unreleased. Our powerful radio telescopes have not been used to listen for signals. We are, for all intents and purposes, flying completely blind into the most crucial phase of this encounter. The only group that is officially on high alert is the Galileo Project, a private research initiative led by Loeb himself. Their network of 3 observatories is designed specifically to detect anomalous aerial phenomena. They will be watching the skies intently in late October and early November, but their coverage of the sky is limited. They admit that if probes are released, they could easily miss them. We will not know what 3I Atlas does at perihelion until after it has already happened. We are suspended in a state of profound uncertainty, waiting for a cosmic visitor to emerge from behind our star and reveal its true intentions. As October gives way to November, 3I Atlas will re-emerge from the Sun's glare, and we will finally, hopefully, begin to get some answers. The world's ground-based telescopes will be able to lock onto it again, and the first critical pieces of data will start to trickle in. The first question will be simple. Is it still there? Did it survive its trial by fire? If it did, the next question will be about its trajectory. Has its path changed? And if so, how? Astronomers will be able to tell almost immediately if its new trajectory is the result of natural outgassing, which acts like a weak, unpredictable rocket engine pushing the comet around, or if it shows signs of a precise, deliberate course correction that cannot be explained by natural forces. This will be a key moment of truth. At the same time, we can only hope that the radio astronomy community will have finally decided to point their dishes at the object. If it emerges from behind the Sun and we suddenly detect structured artificial signals coming from its direction, we will enter completely uncharted territory as a species. Such a discovery would instantly vaporize our fundamental assumptions about our place in the cosmos. It would test the ability of every government on Earth to manage a real-time first contact scenario. Avi Loeb has developed a Loeb scale to help classify the likelihood of an object being artificial and the potential threat it might pose. He has stated publicly that based on the current evidence, he would not rank 3I Atlas any lower than a 2 out of 10. This means that even in the most conservative, best-case scenario, the anomalies are simply too numerous and too significant to be dismissed out of hand. They demand serious, continued investigation. We are currently caught in the agonizing space between the probable, mundane explanation of a natural object and the small, but non-zero, possibility of a technological artifact that could change the course of human history. Our next best chance for clarity will come from another ESA spacecraft. The Jupiter Icy Moons Explorer, or JUICE, will be in a position to observe 3I Atlas between November 2nd and November 25th, right after it clears the Sun. This is excellent news. However, it comes with a frustratingly long delay. Due to the vast distances involved and the time needed for data communication and processing, the data from JUICE's observations will not be fully available to the public until February of 2026. This means we will have to endure another 7 months of uncertainty. We will have to wait to find out if the activity JUICE observes is the normal, predictable behavior of a comet recovering from perihelion, or if it is something else entirely. We will be left to wonder, for 7 more months, if the fuzzy, insignificant dot we were shown back in October was a deliberate and calculated downplaying of a much more significant, and perhaps much more terrifying, reality. The entire sprawling mystery of 3I Atlas forces us to question what we think we know. It challenges our assumptions about comets, about trajectories, and about the likelihood of visitors from other stars. But what if the problem is even deeper? What if our entire model of the universe itself is wrong? In a fascinating parallel to the 3I Atlas story, a radical new paper published in October 2025 is proposing just that. It suggests that the two biggest mysteries in cosmology, dark matter and dark energy, might not exist at all. For decades, the standard model of cosmology has been built on a strange and uncomfortable foundation. It holds that everything we can see, the stars, the galaxies, the planets, us, makes up only 5% of the universe. The rest, we are told, is composed of two invisible, mysterious substances. About 27% is dark matter, an unknown type of matter whose extra gravity is needed to explain why galaxies don't fly apart. The other 68% is dark energy, an even more mysterious force that is causing the expansion of the universe to accelerate. We have built our entire understanding of the cosmos on substances that we have never directly detected and do not understand. Now, a new paper by physicist Rajendra Gupta proposes that we might not need them. He suggests that we may have been looking at the problem backward. Instead of inferring the existence of invisible substances to make our equations work, perhaps the equations themselves need to be revised. Gupta's theory proposes that the fundamental forces of nature, like gravity, are not constant. Instead, they are slowly weakening as the universe ages. This concept of time-varying constants could, he argues, explain the observed accelerated expansion of the universe and the rapid rotation of galaxies without ever needing to invoke dark matter or dark energy. This idea comes at a time when the standard model is already showing cracks. Years of incredibly sensitive experiments have completely failed to detect any dark matter particles. Recent data from the James Webb Telescope suggests that dark energy may not be a constant force, as previously thought. Gupta's model is an attempt to provide a single, unified explanation for all these nagging inconsistencies. Now, overthrowing a decades-old successful scientific model is incredibly difficult, and his theory will face immense scrutiny. But it highlights a fundamental debate at the heart of science. Are we seeing the universe as it truly is, Or are we just seeing the universe through the lens of our own assumptions? Is the reason we can't find dark matter because it's incredibly elusive, or is it because it simply isn't there? This is a perfect metaphor for the three-eye atlas situation. Is it a comet that just happens to be weird in a dozen different ways? Or is our fundamental assumption that all interstellar visitors must be natural objects, blinding us to the truth? Just as cosmologists may have invented invisible substances to save their theories, perhaps the mainstream astronomical community is inventing a string of improbable coincidences to avoid confronting a possibility they find too uncomfortable to consider. New observatories, like the Vera C. Rubin Observatory, will soon be able to test these cosmological models with unprecedented precision. And in the same way, continued observation of Three-Eye Atlas will soon test our assumptions about our place in the universe. The lesson here is one of scientific humility. We must be willing to question everything, even the very laws we thought were written in stone. Ultimately, the story of Three-Eye Atlas isn't just about a mysterious object in the cold, dark void of space. It's a story that reflects back on us. It holds up a mirror to our own technology, our own progress, our fears, and our aspirations in this pivotal year of 2025. It's a story about the human element. Think about where we are as a species. On October 8th, while the world was debating blurry photos and government shutdowns, Blue Origin launched its 15th successful space tourism mission. What was once the exclusive and dangerous domain of government-trained astronauts is now becoming a commercial enterprise. Companies like Blue Origin and SpaceX, with their revolutionary reusable rockets, have shattered the old paradigms and dramatically lowered the cost of escaping Earth's gravity. This isn't just about joyrides for the wealthy. This is the crucial, foundational work for building a multi-planetary future. Ambitious projects like SpaceX, Starship, and NASA's Artemis program are no longer science fiction dreams. They are active engineering projects aiming for a sustained human presence on the Moon, and eventually the first human footprints on Mars. We are, at this very moment, taking our first, tentative steps off our home world. And it is at this exact moment that a seasoned traveler from the great interstellar ocean may be passing through our cosmic harbor. The juxtaposition is poetic and profound. Our motivations for this expansion into space are both pragmatic and deeply aspirational. We are driven by the pragmatic need to ensure the long-term survival of the human species, a hedge against the catastrophes that could befall our single, fragile planet. But we are also driven by something deeper, that innate, insatiable curiosity to explore, to see what's over the next hill, the next ocean, the next planet. And look at how interconnected our progress has become. This expansion into space is not happening in a vacuum. It is deeply interwoven with all the other breakthroughs we've discussed. The quantum computers we're developing could one day optimize the navigation for interstellar spacecraft. The fusion reactors we're building in our labs could provide the advanced propulsion to get us there. The artificial intelligence we are creating will be absolutely essential for managing the complex life support systems and robotic operations on distant worlds. Progress is not a series of isolated spikes, but a web of cross-pollination, where a breakthrough in one field accelerates discovery in all others. We are building a new human capability, piece by piece. This is the ultimate context for the Three-Eye Atlas mystery. It arrived at a moment when humanity is poised on the brink of its own technological adolescence, just beginning to wield the kinds of energies and intelligences that would be required for interstellar travel. Whether Three-Eye Atlas is a rock or a reconnaissance probe, its passage is a profound and timely reminder of our own place in this dynamic and likely crowded universe. The year 2025 has been a year of cosmic whiplash. We've been reminded of our vulnerability by an asteroid that slipped past us undetected, and gifted moments of beauty by comets gracing our night sky. We have witnessed the birth of moons around a distant star, a process that may create countless cradles for life. We have seen our own technological prowess mature with quantum computers that defy classical logic and fusion reactors that bottle the power of a star. We have found potential fossilized hints of life on our nearest neighbor Mars, while simultaneously questioning the very existence of 95% of our own universe. Each of these breakthroughs, each of these stories, carries both immense promise and a heavy weight of uncertainty. The confirmation of extraterrestrial life, the advent of practical fusion energy, or the creation of true artificial intelligence could transform human civilization in ways we can barely comprehend. But these powerful technologies demand not just technical skill, but wisdom. They require ethics, foresight, and a deep sense of responsibility to ensure they are used for the benefit and not the detriment of humanity. And that brings us back, one last time, to that fuzzy white dot. The story of 3I Atlas has become a lesson for our time. It's a lesson about the critical importance of questioning official narratives, of demanding evidence, and of not being afraid to ask uncomfortable questions. In an age of information overload, digital censorship, and algorithmic manipulation, the ability to think for yourself has become a survival skill. But more than that, it's a lesson about staying curious. It's a reminder to look up, to look at the night sky not as a static backdrop, but as a dynamic, living place filled with mysteries that are just waiting for us to unravel. The search for answers, whether it's about a strange visitor, the origin of life, or the nature of the cosmos, is a continuous journey. It's the process of discovery itself, filled with all its challenges, its frustrations, and its new, unfolding mysteries, that truly propels us forward as a species. We are left here, in late October 2025, in a state of suspense. We are waiting for an object to emerge from behind the sun, an object that could be nothing, or could be everything. So now I turn the final question over to you. After hearing all the evidence, the anomalies, the leaks, and the silence, what does your intuition tell you? What is the truth behind 3I Atlas? Is it a once-in-a-generation cosmic coincidence? Is it a coordinated global conspiracy to hide a profound discovery? Or is it, finally, first contact? Please, leave your thoughts in the comments below. Let me know where you are watching from in the world, and what you believe is happening in our skies. Thank you for joining me on this deep dive into what is truly an unfolding historical moment. I wish you and your loved ones nothing but good health and clear skies. Take care of yourselves and each other. And if you found this investigation valuable, please like this video, share it with others who need to see it, and subscribe to the channel for future updates. The story of 3I Atlas is far from over,